喂喂，能听到我说话吗？请大家这边一起开一下摄像头吧。
Ladies and gentlemen, we invite you to turn on your webcam. Thank you very much. Now I will share my screen with all of you. And we will begin the training camp for the day 3. Today, we're going to do a technical communication, and we will be focusing on the library that are Pillow, NumPy, SciPy, and OpenCV. Now let's go to the Pillow library.
数字图像，图像是视觉的基础。通俗的来讲，图像就是所有具
The
有视觉
digital
功能
image
的
is the
方式
basis of vision.
反映
Generally
人对物
speaking,
体的认知，
image
包
is the
括纸
picture
上的
with
图
visual
片、
effects reflecting
图片
people's cognition
或者
of
是在
objects,
屏幕上的，
including types
通
of
过拍
paper,
照、扫
film,
描、
negative
录
film,
制、微信视
projection,
图
or computer
绘
screen.
制得到的。
It is obtained usually through photography, scanning,
比
recording,
如我们现在
satellite recording. For
现
example,
在我
this
们
PowerPoint,
在我们眼
it
前，我们也可以
shows
称之
you
为
on the
一张图
screen,
像。
and we can also call it an image.
第二点，根据图像
The
记录
second
的
part,
方式，图像可
according to the
分为模
ways
拟
of
图像和
image
真实图
recording,
像。
it can be divided into two types, one,
模拟
analog
图像可以
image
通过
and
某
digital
种反
images.
亮、光、
For
电、
the analog image,
电
it can
来
report
记
the
录图像的亮度
image
信息。
brightness information through intensity change of a certain physical quantity, such as light or electricity.
数字图像
For
这是计算
digital
机储存
images,
存储数
it
据
is
来
a
记录
way
图
for
像
the
上的亮
computer
度
to
信息，
store
图
data
像处理一
or
般指的是
digital
数字图像。
signals to record the brightness information of each single point.
数字图像又称为数位
Digital
图像、
image,
数码图
also
像，
known as
是
digit
模拟图
image,
像的绘图、
numerical
亮
image.
度和色彩的数据化。
It is
数
for
字图像
digitalizing the
将连
grayscale,
续感知
brightness,
数
and
据
color
进
of
行数
analog
据的转
image.
换，转换为数字
Digital
的形式。
image is to convert
数字图像的
continuous
空间是
perceptible
理想
data
的。
into digital form by data conversion. The
数字
space
图
of
像
digital
通常表
image
示为一个
is
二维矩阵，
discrete.
使用二维矩
A
阵，
digital image is
使
usually
用二维数字
represented as
FXY 表
a
示。
two-dimensional matrix.
XY 是图像
It
和
is
空间的位
usually
置坐标。
presented by
在
two-dimensional
表示
array
该位置
that
的
is
信
x
息。
and y. X and y are the position coordinate.
图像的深度，图像的深
The
度
depth
是
of the
指存
image.
储每个像素
The
所用
depth
的
of
位
the
置，
image refers
也
to
用
the
来
number of
测量
bytes
图像色彩的
used
分
to
辨率，
store image pixel,
也就是我们俗说的图像
and
的
is
深度。
also used to measure the color
单通
resolution
道
of
或
the
者
image.
单通道都是
For
图
example,
像的深度。
for example, the three channels
二
or
维图
single
像指
channel
图像的像素点不是零
binary
就是一，
image means
非黑
that
即
the
白。
pixel of the image are
图
either
像像素
0
点
or
占的
1,
位数就是一位，图像的
and the
深度
bit
则
number of
是
an image
厘米
pixel
的，
is
也称
1,
为
and
维
the
度。
depth of the image is 1
灰
bit,
度图像即
also
上述
known
每个
as the
像素点
bitmap.
占8个字符，
Grayscale
2个
means that
8次
each
方，
pixel
1
above
乘5，
occupies
深度为
8
8 bit，
bytes,
代表
with the
256
depth
个图像的
is
灰度，
8
0 为
bit,
全黑，
representing
25为全白。图
256
像的
levels
深
of
度决定
grayscale.
了灰度图
0 is all
每个
black,
像素的灰度级数。
255 is all white. Image depth determines the gray level of each
白
pixel
色图
in
像
the
大多为
grayscape map.
24 bit， 可以表
Color
现
image
24
are
次方
usually
不同的颜色。
24 bits, which can
彩色
represent
图
different
像通过
colors.
通道数来决定，
The color image
深
is
度决定
determined
了
by the
彩
numbers of
色图像
channels,
中每个像
and
素
the
的色
depth
彩数。
determines the color number of each pixel in the color image. Now we will talk about the pixel value. With the concept of image depth for a 24-bit image, the value range of this color of this pixel is from 0 to 2 multiplied 24. The channels of image decompose the image into one or more color components. The number of channels for grayscale image is 1, and the number of channels for color image is 3. One pixel only needs one numerical value representation, which is called a single channel. It is it is worth noting that a single channel can only represent binary images or grayscale images. You can see these two images. The first one is the binary image, and the second one is the grayscale image. We can see that in the first picture, there's only white and black. And in the second picture, there are gray, black, and different level of black, and white, and different level of white. Now we're talking about the image channel. One pixel will be described by three colors, and it is called the three channels, such as the three original colors. If we use 8 bits to represent a color, each color is up to 255. So a 24-bit color image can be described as a combination of RGB 3 primary colors, and a range of color values for each pixel is red 0 to 255, green 0 to 255, and same as blue. On the basis of RGB, the transparent channel alpha is usually used to express that the transparency is 4 channels. Here we go to the Pillow library basis. The Pillow library, also known as the Pill library, is a free open source third-party image processing library of Python. It is mainly used for basic image processing, such as cropping image, resizing images, and image color processing. The Pillow library provides rich set of functions. The main features are as follows. The first one, it easily reads and saves pictures in various formats, such as JPEG, PNG, GIF, TIFF, etc., etc. And it supports conversion between each image format. The API interface is simple and easy to use, and many image processing tasks can be easily completed. The image object in the Pillow library can be converted from NumPy and ND arrays. The most important class in the Pillow library is the image class. The image object is created through the image class. And various image processing methods are used to implement the basic operations on the image, such as opening, reading, saving the image. This is how to import image class. This is how to import image class. As you can see in the screen, this is the way to import it. Use the open bracket method of the image class to create an image object to open the image. And in the frame shown below are the ways to import. The first one, FP, is the abbreviation of the file path, which refers to the storage path of the image. It has to be in string format. For example, if we try to import a list, we cannot operate it. Mode means the image mode. Optional parameter and formats are the image format. Those are both optional. The common properties of image projects are size. Obtain the width and height of the image, which is called pixels. Format, that represents the format of the image, commonly including JPEG, PNG, and other formats. Mode, which indicates the mode of the image, that defines the pixel type and image depth. Common modes are the RGB, HSV, etc., etc. Here, L represents the luminance and grayscale image. RGB represents a two-color image, and CMYK represents a pre-compressed image. The first two ones are common used. Here we go to the thumbnail. Thumbnail image refers to reduce the original image to a specified size, which can make the image easier to display and browse. For our model, it could be allowed to resize to a specified size for us to use. The image object provides the thumbnail methods to create thumbnail image. It is worth mentioning that thumbnail can only perform the operations of shrink, while resize can operate scaling, that is, shrink or enlarge. Converts, that is, to convert the current image to another mode and return to a new image. If no mode is specified, then it automatically chooses a mode that retains all the information to an image and does not use the text. Here in this frame, those are the modes and the descriptions. If input 1, that means 1 bit pixel, black and white, and each byte stores 1 pixel. L, I, or F indicates grayscale image of different bit pixels. Here, YCVCR means 3 multiplied 8 bit pixel with the format of color video. HSV indicates human perceptive color patterns, and HSV represents hue, saturation, color space, respectively. RGB indicates 3 multiplied 8 bit pixel, true color image. And RGBA represents the 8 here represents the transparency
Recording stopped.
of 4 channels. CMYK indicates 4 multiplied 8 bit pixels, and this is the print mode. LAB means the space of 3 multiplied
Recording in
8 bit
progress.
pixels. Rotate. This is to set the rotation angle operation on the image, and the rotate counterclockwise when rotating and returns to a new image object. Transpose methods, that is to flip the image or other operations. It is worth mentioning that here flip and rotation are different, and this is flipping. Rotation are clockwise. So those are different. To transform an image, the way of transform is to generate a new image with the same size as the original according to the given size. The image class provides copy and paste methods for copying and pasting. And here, the split indicates separate color channels, as well as the merge color channels, that is the image dot merge, and we directly import mode and channels. In image filter model in Pillow, implement image notice reduction applications. Many image enhancement filters are defined in this module for smoothing, sharpening, and boundary enhancement of the image. Image filters are mainly to solve two problems. The first one, effectively remove noise, that is called interfering information, in the target and background. And second, protect the target shape, size, and specific geometric and topological features of the image. The first method is blur, that is the blur filtering. After the processing, the whole picture will become blurred. The second one, detail, that is to make image finer and more obvious in detail. And the third way is to look for boundary filter to find marginal information in the image. And the fourth one is the boundary enhance filter to enhance the edge of the gray area and highlights the edge on the original image. This is the end of the pillow library. Now we go to the second library, that is NumPy. Now I'm going to introduce NumPy and digital images. The image is a matrix composed of the height W multiplied the width H pixels, which each pixel has a value of range of from 0 to 255. Each pixel value expresses a different gray value. Taking a common RGB color image as an example, each pixel has 3 channels, and the metric structure of the image is expressed as the height W multiplied with H multiplied the number of the image channels. The height is regarded as number of the rows of the array. The width is regarded as the columns of the array. NumPy loads images into ND array form for operation. Method 1, load the image with the pillow library and convert it to an array. First, we import the PIL library, and then import NumPy, and then through MP array to convert it. Method 2, load the image with matplotlib, and the image loaded by imread bracket is an ND array. Same way we import NumPy as MP, and we use imread to operate it. And the mode and format of the image will be in the array mode. In NumPy, images are represented as an ND array objects, and the saving of images is regarded as saving ND array objects as images. Method 1, use the library PIL, the form array bracket, to convert the ND array data into an image object of PIL. First, we convert the image to this object and utilize image object to save it. Method 2, save with imsave bracket method by matplotlib. Grayscale converting. Taking an RGB color image as an example. The image gray is represented as the height, width, and number of the channels. Here, it is a 3-channel, and the number of the channels for a grayscale image is 1. So the grayscale image can be understood as a 2-dimensional array. Similarly, the pixel value is from 0 to 255 or 0 to 1. While all 0 is black and 255 is white. following the human eye's perception of color. When converting a color image to a grayscale image, the colors of the three channels of RGB will be converted with different proportions, and the conversion formula is as shown in this PowerPoint. The L is the pixel value of the converted grayscale image, and RGB corresponding to the pixel values on the three channels respectively. 0 of the grayscale image is black, 255 of 1 is white, and the values of range shows grayscale effects of different brightness. The formula of converting a color image to a grayscale image can be understood as a dot product operation, and the dot bracket function in NumPy. NumPy image processing. The geometric operation of the image means that the pixel value of the image is not changed. Only the pixels are rearranged on the image plane to realize the space transformation of the pixel coordinates. So in a sense, the range of the matrix is different, but the pixel value does not change. The common geometric transpositions are image rotation transposition, image mirror transformation, that is horizontal and vertical mirror, and translation transformation and scaling operation. NumPy image processing. Here we give an example. We rotate the image horizontally by 90 degrees. Essentially, we move the position of the pixels. For example, we remove this row to this column, and so on, as it shows in each of these squares. And this is a 90-degree clockwise rotation. NumPy image processing, that is using NumPy to implement image rotation operations to swap position of the data in the matrix. Up and down flipping and vertical mirror transformation. Image is to up and down flipping along horizontal line in the center of the image to swap the positions of the rows. And the first row, as is shown in this page, the first row becomes the last row, and the second row becomes the second row from the bottom. Here, this is the method to operate rotation. We're loading, and we use the operation of sliding. Here, the -1 represents reverse order, and to realize the exchange of the position. And then the second picture is the display of the image. As you can see, that this image is rotated. Next, we'll talk about the SciPy library. SciPy is based on the NumPy, and it is an open source library for numerical operations, such as linear algebra, statistics, optimization in Python. The introduction to the main function modules of SciPy. The first one is the module, and the second one is the description accordingly. And the first column and the third column are the same. Both are the modules. The first one is to do the cluster analysis. The second one is the mathematical constants internally. And the third one is the Fourier transformation. And the fourth one is the numerical integration operation. The next one, interpolation operation. And then next, signal operation. Next, sparse matrix. we usually use the sparse matrix.
最后一个这个方法是
The last one of this column is the space data structure algorithms, and this one is not commonly used.
这第一个方法是数据的输入输出，
And the third column, the first one is the data input and output.
第二个方法是
The second one is the linear algebra.
进行一些算法
In
的时候
this
会
one,
经常用到这个
we
方法。
do the algorithms and we usually
三个方法
use
读取文
these
件以及
methods.
测试
The
图
third
像。
one, read files and test images.
第四个方法 N 维图像处理。
Fourth one, that is the n-dimensional image processing. This one, we can connect it to the last page we introduced, that is the NumPy.
可以这样等同的去理解。
And we can regard it as the same. The next one is the orthogonal distance regression. Next one, special mathematic functions, and it is also not commonly used. Next one, this is the statistic toolkit.
最后一个
And the last one,
咱们经常训练模型知道这个 optimizer 是优化器。
this is the numerical optimization algorithms.
这个 ND image 这个模块
ND
用
image
于多
model is usually used to operate
方法有图像的移动
multi-dimensional images.
还有图像的过滤操
Commonly
作
present methods
以及
include
平滑
image movement,
降噪操作
rotation, fading, flipping,
这里是
image
图像
filtering,
直接从 CPython
smooth,
导入
and denoising. And this is the way to import ND image.
图像处理的基础操作有
The basic
选段、移动、
operations of
播放
image processing
以及
include
下面四个模
rotation,
块
movement,
第一个方法是
scaling,
图像
which
的直观
correspond
操
to
作
submodels respectively.
第二
The
个方法
first
是
one
图
is
像的移动
rotation.
操作
The second one
第三个
is
方法是图像
translation.
的缩放操作
And the third one is the scaling of the image.
这里来通过具体的代码看
Here
图
I
像
will give
向
you
前
a
转
code
是
to
怎样操作的
understand how to rotate the image.
方法是这个 nd image 点
And this is
rotate
the method.
里面
We use ND image and import
旋转的度数
image
以及最后的
and
模式
take the degree and the mode.
第一个参数 image 表示输入的
And
图
the
像
first parameter, img, means the image inputting. The second angle means the degree of the rotation. And the third one, mode, is the fitting method of the back area after rotation. The default is constant backfitting, and other methods are. The first one, reflecting filling, which is mirror
第
effect.
二个是以就近的像
The
素前
second
后
one is to use the nearest pixel to fill.
类似于这
And
个
the
方
third
法
one, mirror, is similar to the
反射
reflect
填充
filling,
不显示最近的
but
像素
it does not display the nearest pixel. And the last one is to fill with original image.
图像滤波
Now we will talk about the image filter. Image filtering is an image modification or image enhancement processing technique commonly used image smooth operations, also known as
实现图像的平滑
denoising,
对话操作以及
image smoothing, sharpening, age enhancement to achieve by different filters.
过程类似
Second,
于卷积其中输入图
the
像
operation of filtering is a neighborhood operation, and the process is similar to the convolutional operation.
对应输入像素
In
领域
each
中的像
of
素的
the
值应用算法来确定
value given
邻域是
in
指当前像素点周围的
image,
像素点
some algorithms to the value pixel in the neighborhood of the corresponding
常用的
input
滤波
pixel. The
有
common
滤
used
波
filters
均值滤
are
波以及高斯滤
median
波
filter, mean
最常用
filter,
的就是第
and
三个方法
Gaussian
高斯滤
filter.
波
And the Gaussian filter is the mostly used in daily life.
我们来看最后一个库 OpenCV
Now, let's look at the last library, that is the OpenCV.
OpenCV
OpenCV is an open source function library for image processing, analysis, and computer vision, which can run on Linux, Windows, Android, and Mac OS operation systems. It consists of a series of C functions and a small number of C++ class, and it also provides interfaces in languages such as Python, Ruby, MATLAB that implements many general algorithms in image processing and computer vision. It has become the most powerful research tool in the field of computer vision. Now we will talk about the difference between image processing and computer vision. The first one, image processing focuses on the manipulating images, such as enhancement, restoration, denoising, and segmentation. And the second one, computer vision focuses on the computer to simulate human vision. So simulation is the ultimate goal of computer vision. If you understand the concept that it is impossible for the computer to totally simulate human vision, we use a series of convolutional operations and through the calculations of functions to extract some features. So it is not totally reach the destination by understanding. It is simulating through a series of operation and calculation. Now let's look at the next page. OpenCV uses Python to package C++ with excellent running speed, concise and efficient code syntax. Also, OpenCV supports NumPy, which supports matrix operations and scientific calculations of image arrays. Here, this is the method to install OpenCV. And this is the screenshot of the installing. Use this way, we will directly install the latest version. When using Anaconda to manage the environment, it should be noticed that the version of OpenCV Python needs to be correspond to the Python edition. Method to import CV is to type in import CV2. I remember that I have a student who asked that why is it import OpenCV? You have to remember that here you need to type in the import CV2. Here is the notice. First one, the installation is using OpenCV Python. So while using it, you have to remember to import CV2. Some versions of OpenCV and PyCharm are incompatible and cannot automatically complete the code, but it doesn't affect the operation. It is because some of the paths are not compact to the package of the Python. That's why there's no code in some of the Python operation. In the previous study, let's take RGB as an example, which is shown in the picture. And each color represents the color respectively. In OpenCV, the sequence are BGR. So through OpenCV, in this time, we will need to convert it and change the R to the first line and change B to the last. In this way, we can achieve the conversion. We can also use the method of NumPy to read it in, and it will be a three-dimensional array. And we can change the last byte to the first byte, so we can manually achieve the conversion. Now this one, it takes the upper left corner of the image as the origin. Usually we use another angle as the origin, but here we use the left upper corner as the origin. Here the column data corresponded to the x-axis and the row data corresponds to the y-axis. As I mentioned here, the column is like this, so that we can see, for us to better understand it. And on the x-axis, if the byte is 1, and it will be like at here. And if we set it to 2, and it will be twice bigger than this one. So on y-axis, it is vice versa. And this is how we understand this sentence. OpenCV library for image processing. mRead method is to load images. mShow, that is to display the image. The windows will self-adapt to the size of the image. mWrite is to save the OpenCV image, which is a multi-dimensional array after reading. And next one, the function converts to the BGR format to RGB format to realize color space conversion. And this is the threshold. Here, this function is to implement threshold operation on the pixel value of the grayscale image to achieve image binarization. Here, OpenCV provides video capture. And video writer classes to support video streams in various formats. Here it reads the video stream frame image through the read interface and obtain basic properties of the camera through get method. The last one, name window bracket. This is to create an OpenCV window. While we display the image, there's a window that we can name it with name window. Next one, library of image processing. Mathematical expression of a fine transposition refers to the process of performing a linear transposition and a translation in a vector space to another vector space, as it is shown in this page of the PowerPoint. Here, this is the affine transformation from the image 1 to the image 2. Affine transformation will cause the changes in the shapes and position of the image. It is a combination of image scaling, rotation, flipping, translation, and miscutting operations. It is often used in image pre-processing operations for deep learning. In the image enhance process, we can use it to operate it. In mathematical ways to understand it, it is as mentioned in the first part. And the effect is shown in the image 1 and image 2. And
rotation
the last
以及这个
one
NRD
is to generate
可以生
the
成
affine matrix M by get rotation matrix 2D.
M 是我们赋予的这一个变量，可以这样说。
M is the bit we give to the matrix.
OpenCV2 呢，OpenCV 库呢还有以下的方法 ，CV2 点 resize
And CV2 resize. In this way, we reduces and enlarges the image.
这个是赋予函数，可以实现
And a fine function here shown is to realize image translation,
沿着 y 方向
movement,
构造移动
and matrix M is constructed along the dx distance
下一个
and
是
the
图像
dy
伸展
distance
操作
in the
通过
y
这个
direction.
这个
And
方
next
法
one,
来
image
实现
mirror
图像
flip
的反馈
operation
操作。
via the
这
method
个
of
CV2 点
flip bracket.
这个
As it is shown in this
按着
page,
这个
it is
y
to achieve image fusion.
可以通过这两个方法来实现图像的融合，直接进行相加。这个是
And it is
下面这两个
directly
方法呢是实现图像
use them
模
to
糊的
plus
流
all
程化。
together. And the next one is to realize the image histogram
最后一个方
equalization.
法这个 split
Last one here,
2/2 是
method
实
provided
现
here
通道的
is
分离
to
和
realize the
固定。
separation and merging of the image channels.
最后的方法用的比较多，前面的方
The
法
last one here,
不多。
the methods are commonly
参加过
used.
咱们第一天训练营的选手应该知道，
The
第一天
participant
的
who
时候
joined the
我们
first aid training, I mentioned
知道 RichNet 网络是用了
that
一个
RichSite
跃层
net
连接，
is to
跃层
use
连接呢
a
就如果是能
cross-layer
实现的话，
connection.
就会用
If
到
we
图
achieve
像
it
融合，
manually,
图像
we
的
will
相加，
need to
通
use
过处理以
the
及优化
image
过程
fusion,
图像
that
的
is to
相
plus
加，
them together.
就会用到这个方法。
And this is the method here as it is mentioned.
OpenCV 库呢，这个第一个方法是均值滤波。
OpenCV library, the first one,
设置为淋浴
that is the mean filter. And the meaning of it is any pixel value is set to the mean of the neighborhood k size. The larger the k size is, the blurrier the image is, and the k size must be odd.
小键盘1到9 9宫格
For example, on the keyboard, the number from 1 to 9.
以中间这一个数来模糊的话，那它的一周就是它的零
If we
如果你
if
是
we
一个偶数的
blur
话，那中
if
间
we
是4
blur
个值，那就
the
没
number
办
in
法
the center,
实现
and
这
then it
个
blurred the whole
就
numbers.
是淋浴这种均值的操作。下一个中值滤波，
Next one, median
这个
filter.
呢是任意像素值取淋浴，
Any pixel
按
value
像素排序中的
takes the median of all
这个 k size
pixels
呢也
in the
可视为
neighborhood.
奇数，如
Also, the k size has to be odd as well.
焦岩噪
For
声。
example, 1, 3, 5, or 7, and it is used to remove impulse noise.
下一个高斯噪声，
Next
下一个
one,
高斯滤波，
Gaussian filter.
这个呢保持了边特征。
This one, the age filters are maintained when the pixels in the neighborhood are averaged. The pixel weights at different positions are different. The closer the neighborhood is to the center point, the way the larger the value is.
设置了 x 方向的权重，
Sigma x says the weight
那 sigma y
in
这
the
里呢
x
设置了 y
direction,
方向
and here
权重
sigma x
这
says the
图
weight
这个
in
方
the
法就
y
是去
direction,
除高斯噪声。
and this is for
西
removing
马计算公
the
式在这里，
Gaussian noise. And the sigma calculation formula is here as shown.
最后的两个方法
The
分
last
别
two
是
methods
图像
here
腐蚀以及图像膨胀，
respectively
这个
realize
俗
the
称腐蚀
erosion
腐
and
蚀操作、膨
expansion
胀操作。
of the image, and it is usually called the erosion operation and expansion operation.
那咱们的 PPT 演示就到这里了，看看
Now
大家
these are all the
对于
display for the
本章节
PowerPoint.
的那个 PPT 本章节所讲到的知识点有什么问题吗？可以直接
If
comment
you
区
have
或
any
者
questions, if you have
通过聊天
any
交流。
questions of this chapter, you can turn on your mic and present the questions or communicate.
有选手提问：图像处理会指定只能用某个模块吗？这个会的。
We have the question here that during the competition, image process will be appointed to a certain model. The answer is yes.
但如果指定的模块、指定的
However,
库
if the
都不锁
appointed
链，比
library
如说
is not used,
咱们这里讲到了 SciPy，讲到了 OpenCV，
example,
还有
the SciPy, OpenCV,
前面的 NumPy 这些科学
and
计算工
NumPy,
具，
some
你
of
只要用
these
其中，只
libraries.
要实现了这道题的目的，那
You can use either
都
of
是可以
these
实现的。
libraries to achieve the requirement of these
有些
questions.
同学
You
问到
will
这上是
get
有分数
the
的，
points.
但是会肯定没有用指定的方法得到的分数高。 问题了，我因为在聊天框里也回了一部分，
Anyone who
然
has
后语
any
音也回了一部
questions?
分。下来就把训练营中介绍的这几个库好好练习一下。
After the
有
training,
问题
I
的话
will
和第一次一样，
encourage
在
you
群里或
to
者
do
在
some
这个群
practice
中直接
with
提
all
问
of these
提问就可以了。
libraries mentioned
那
in
咱
the
们
training
会
camp.
议今天就到这里吧。
And if there's no further questions, we'll call it an end for today's training.
那咱们今天就到这里。
好的，谢谢各位专家和各位选手。
Ladies and gentlemen, this is the end for today's training.
好，谢谢各位专家和选手。那小雨姐，你那边就结束会议吧。